Alright, awesome. Here we are. Let's update this title. Today we're not automating network management. Today we are setting up some Prometheus host monitors. So, one last thing to do. Let's share this link. Okie dokie. And away we go. So, what are we doing tonight? Well, we have this awesome monitoring platform here at Memphis HamWAN called Prometheus. It's essentially a time series database optimized for application monitoring in collecting health metrics. It's not log ingress. If you're familiar with the ELK stack with Elasticsearch and then with Kibana, it's not that at all. Prometheus, in my mind, is tuned specifically for metrics, usage of resources, occurrences of individual activities. It's good to track the health of systems. It's not good to go back and look at, say, historics of why something may have happened. Metrics tell that story in part, but qualitative data like logs through the ELK stack are fantastic, and they have their own place. Today, we're focusing specifically on the quantitative, things within the Prometheus monitoring stack. And I say stack, Prometheus in our case is actually augmented by a number of other related projects. What we want to do tonight is make it where we get notified when some of our network appliances go down. Specifically, I'm talking about our network cameras. Now let me put my hands on that. What does that mean? Well, HamWAN and Memphis Metro, let me take this bone away from my dog before this goes crazy. Alright, HamWAN and Memphis Metro, we've got network cameras at some of our network sites, at our points of presence. And so you can see that here's a network camera that we have that's actually in Midtown Memphis. So this is a live camera feed right now. And we can pan tilt and zoom around and, you know, hey, there's a person walking on the sidewalk there. And by the way, there's a Yagi antenna there in the field of vision. But, you know, if we want to get real creepy, we can, you know, zoom up here as far as it'll go, and or pan up, rather. And then, I guess it's tilting, technically. Nothing more in terms of zoom in that we can do, but there you go. I mean, it's a network camera. It's an appliance. Why do we have it? Well, in my opinion, it's a useful application of the network itself. Oh, there we go. Okay, I was using the wrong button before. It's a way to prove that connectivity works. It's a way, for instance, to go back and look to see that our equipment is still installed appropriately without requiring a visit to the site physically. It's also a way, in certain situations, to look at environmental events, whether that's man-made or ecological. So whether it's weather, or whether it's something like, say, a big crash or a wreck on the interstate, that kind of thing. So that was our Midtown site, and then over here, here's a view looking to the due west from East Memphis. So that's the downtown city skyline there. That's Clark Tower, and this is the interstate right off of the building. This is installed on a rooftop of a very tall building at Poplar 240. So anyway, we've got these appliances. This is my personal favorite. It's our network camera looking downtown. Here you can see the Bass Pro Pyramid. You can see a portion of the Hernando de Soto or M Bridge crossing the Mississippi River. You can see the bay side, the harbor side of basically it's a Wolf River outlet. So it's a fun place to be. This is Front Street right here. Anyway, so what's the problem? Well, all these network appliances today, they're IP cameras. They're things that we don't really get to install software on. And so we don't really have good monitoring of these. We could see if these two, we get a no signal, but that requires somebody going and looking. We want to have a proactive monitoring approach, and we want that proactive approach to be something that follows what the network usage should be. We want to actually have it follow what the service should be, what's meaningful to people. So if something's plugged in, it's a start, but that doesn't really answer the question of is it working? And of course, we want to get as close to the user's perspective for what working means as we can. So in our case, let's start with saying, okay, what's the status quo? Well, we use Prometheus along with a sibling application called Alert Manager in order to first keep track of the performance of our systems and then alert, send notifications and then manage silencing notifications when certain events take place. So that might be a disk running out of space. Or in this case, it could be a host not being reachable on a specific TCP port for a certain amount of time. So it's important when you consider this kind of monitoring that you're familiar with what the device's configuration is. You need to know what it means to work. In this case, it means that the camera is going to be responding to a request on a specific protocol, in this case with a specific port. I say TCP, it's RTMP, I believe. No, RTSP, I believe. And that's port number 554, but that could be protocol UDP. I don't really remember. We'll dig into that here in a second. But for now, let's go over kind of what the setup looks like. So I already mentioned that we're using Prometheus. And I already mentioned that we're using Alert Manager. Prometheus in itself takes care of basically retrieving these stats, storing them in a time series database, and then exposing them in this web server interface. But this web server interface, this is not Prometheus. Prometheus at its core is a combination of those three things together. Prometheus, most importantly, is the time series database. So let's take a quick look here and say, well, what's Prometheus actually set to do today? In their web UI, you can go and look at the targets. And so in our targets, you can see all of the different things that Prometheus is reaching out to. Now, the way that this list of targets comes to be is a more advanced topic for a future discussion. But what we care about here right now is just doing a little bit of intel. Are we keeping track of any network cameras? And so what I'm going to be looking for here are endpoints or labels that seem to be related to network cameras. So we have one group of targets called ADSB. Now I happen to know that that is related to our ADSB server, and so that's scraping metrics related to the performance of our ADSB. So that's not it. All-Star. I wonder what that is. Well, it looks like this is actually just a TCP Connect blackbox exporter. Now that's a lot of different stuff here at once. What does this mean? Well, this means that this specific check is looking for traffic on allstar.leb.memhamwan.net on port 5038. You can see that actually listed here. So this probe is going to see, hey, is this instance responding on this port? That sounds pretty close to like the design that we want, but we're not asking about All-Star tonight. We're asking about IP cameras. Now, black box. Here we've got a black box exporter to a black box exporter to this Google URL. That doesn't seem related to this URL for WB4KOG, which I think is just a D+ dashboard. So that's a D-star repeater. And then we have this one that seems kind of interesting, cam1.azo. This is a webcam. Okay, so let's go ahead and take note of this. First is currently being tracked here. Now, what is this actually checking for? What is this black box exporter looking for? Well, it's job black box, it's a probe. It's looking for HTTP 200 is what it says. So that means that this monitor is going and looking on cam1.azo.mmhamwan.net. It's doing an HTTP request, and it's asserting that that should be returning an HTTP 200 result. Let's go back to the previous conversation. Is the webcam serving an HTTP 200 indicative of the webcam working, of it streaming a video? Close. It's better than a ping. It means that a web server is running and that some application on the server is giving success results. But it still doesn't mean necessarily that the specific integration with Blue Iris is working. And this is, to us, the definition of is the webcam working. So this is close, but it's not exactly what we'd want to see. So let's go back to the list of targets. ais.azo.mmhamwan.net. Well, that's not it. That's the AIS server. It's a boat tracker. So that's not related. That's not relevant. Then we have this Kubernetes API servers. Well, that's not it. Kubernetes nodes. Well, I can go ahead and say that's not it either. Node C advisor. No, that's not it. Pods within Kubernetes. No. Service endpoints. No. Node exporter. Node exporter is used for actual computing nodes. It's an application written by the Prometheus folks that collects metrics about the specific host itself. So you can see here that some of the metrics that the node exporters surface is like node CPU seconds or disk read time. So it's pretty safe to say for an appliance, node exporter isn't going to be relevant. Prometheus itself and metrics from Prometheus, no, that's not it. Push gateway. Push gateway is actually an interesting case that's used to collect metrics that have been pushed from other devices. And that's not relevant for this use case. Smoke ping. That doesn't sound relevant either. The APC UPSs. Nope. Routers. No. Alright, so we're out of options here, really. So what this means is today, our current state of what we're monitoring, we happen to be tracking one of the webcams. But if you go look, today we have 5 that are operational. And the other thing that we discovered was that the one camera that we're tracking is not actually making sure the video feed is working. It's just making sure that a web administrative portal is running. So let's note that. Alright, I'm going to pause here for a second. Cool. Nobody's watching. And nothing in the chat. Awesome. That's how it goes sometimes. So we've noted in here that, okay, we've only found one device that's relevant for this exercise. Something that's interesting. Well, Prometheus typically expects to go out and retrieve stats from other devices. It's a pull model. You configure Prometheus server to pull stats from other devices. Let me show you what that configuration looks like. So if we go and look at the mono repository that we have for our infrastructure automation, which apparently I can't type. There we go. Configuration. You'll find that we have two folders here called Ansible and Fleet. Fleet is where we have the configuration for our Kubernetes deployed services. These are Fleet managed applications using the Rancher Fleet platform. That's where we're running Prometheus today. And if you go and look at the actual Prometheus configuration, you'll find in here all sorts of information about where we've deployed Prometheus using Helm. Now the thing that we're specifically interested in tonight is what's the configuration for Prometheus itself? And you'll find that the configuration for deploying Prometheus has this section called server files. And underneath that, there's a specific file called prometheus.yml. This contents is what ultimately makes it into the Prometheus server's configuration file. The other way to go and verify this and kind of validate what the config is, Prometheus lets you go and see its configuration. It just spits into the browser what's going on. I'm going to stay looking at it in GitHub just because that's where we're going to be doing our changes. So you can see that one of the top level configurables for Prometheus is this definition of something called scrape configs. And looking at these, some of these names line up with what we were just looking at when we were looking at targets before. That's because scrape configs, in our instance, is the way that we are specifying what Prometheus should keep track of. So this includes things like saying specifically what the targets should be, what we're going to call the job, because technically each scrape config value is a job itself, where Prometheus should go and request to a target for its metrics. And there's other options as well around parameters to pass to the request, and then also relabeling. Think of that kind of as post-processing on the results before they get added to Prometheus's time series database. So in our case, we found one configuration that was kind of close to what we wanted, and we took note of it on the Jira issue, or on the GitHub issue, and that was cam1.azo. It's not exactly what we want, but it's kind of close. So what's this job? What's a configuration that leads to that happening? Well, we made a job named blackbox. The metrics path is on /probe. We can return to that. Parameters. The module that it's running is HTTP 2XX. So this parameters module, that corresponds with what we saw here. Module, right? So if we go and look at specifically Blackbox's configuration for cam1azo, you can click on the endpoint and that loads the endpoint that it's scraping. So this is what Prometheus is requesting. Prometheus at its core just generates requests to these things, then inserts it into the database. So module HTTP 2XX, where that's being generated is this line right here. Static configs. Targets. There's a list of targets. So what this begs the question is, in our case, we know that we want to have a way to see whether the video is running. Let's start with abstractly saying, how do we know that the webcam's video is running? Well, I think the first thing for us to do is say, well, how is Blue Iris detecting that the video is running? Well, it's accessing the video directly, right? So let's talk about what that looks like. Let's talk about how Blue Iris is accessing these videos. I think the best thing for us to do is to reach out and ask the administrator of this service, Sam. So let's open a chat here. So Sam should answer us here in a second. Now, let's go over what this black box exporter is. I talked about how Prometheus, at its core, scrapes statistics from things. This is the retrieval portion of it. And essentially, the whole architecture here, oh geez, there we go. The whole architecture here depends on a device being able to publish its metrics. But in the case of a webcam, we don't control the software that's executing there. So what I need to do is inject something in between, something that can reach out to the webcam, do some sort of processing, make sense of it, and then publish, so that way Prometheus can retrieve it, publish statistics in a format that are meaningful. So that's what this black box exporter application is. You don't see it depicted on this architectural diagram. It's kind of under jobs exporters. If you do a quick Google search, you'll find this repository, black box exporter. What does it do? It allows black box probing of endpoints. So what we're going to hope for is that these webcams can be probed by the black box exporter and then have the statistics published in a format that Prometheus can ingest. So essentially we're going to have a piece of infrastructure running between the two, putting data in a meaningful format. Now, just like everything else related to our services, the configuration, the deployment, the secret sauce is all in this infrastructure configuration repository. And you'll see there's this black box exporter folder. So right in here, you'll see this is where we pass another configuration. And the black box exporter allows you to configure for things. Here are their docs. So you can see the format for this generally is going to be to have specific modules with a name, and they specify things like probers, timeouts, and then there's additional configurations depending on the prober itself. So for instance, we have a prober that checks to see for TCP connect. A module that checks for TCP connect. And all that really means is that it's going to try TCP for up to 5 seconds. So theoretically, if the webcams speak TCP, then what we should be able to do is tell the black box exporter to use its TCP connect module. We'll specify on the Prometheus side what the port should be, what the host should be, and what that's going to check for. Let's look. We can go so far as to specify what a query response should be, even if we wanted to. We could even make it where the TCP prober sends a request packet. Now, I don't think we need to do that. I don't think that's necessary. I don't think we need anything around TLS. We'll find out soon when we hear back from Sam. And you know what? I said we're going to wait on Sam, but I think what we can do instead is just use our handy-dandy nmap tool. And instead what we'll do is say what ports are open on this device. And it should be able to answer the same question that Sam would. Because if I remember right, these devices are not configured to respond on non-standard ports. And there we go. cam1.azo.mem.hamwan.net responds to our TSP, which is port 554 TCP. So what do we want to do? Today, the way that we've configured Prometheus, is to look for an HTTP 200. But what we really want to do is make sure that real-time streaming protocol, the thing that populates the video on Blue Iris, that's what we care to know works. So what we should be able to do is go through and say, well, let's try to scrape for TCP 554. We already found that the black box exporter that's deployed on HamWAN, it's configured with the TCP Connect module. It looks for TCP connection with a 5-second timeout. So awesome, that should work for us. Now what we can do is jump back over to the other window somewhere. What we could do is, let's take a riff on the various TCP probers that we got here. Here we go, TCP Connect. So All-Star is configured as a TCP Connect to this specific target on this port. I'm not saying that we're going to do it exactly like we did here, but we can use this to kind of build our URL, just to see manually before we run the deployment and write the configuration for Prometheus. Are we in the ballpark? So we know what we want to do is look for this device. So target is this. And we also know that we need to tell the TCP Connect module, TCP Connect module, which port to run on. We just found out that that's 554. So if we run this, it should return successfully. Why? Because the AZO camera, which I happen to know corresponds with this picture, we know it's working. Blue Iris can see it. So this specific scrape represents being able to connect on TCP port 554 to the camera. That is the kind of monitor that we want. So I'm going to quickly add this note. I think that a monitor like this is closer to what the user sees, and therefore we should track. Now, what about all these other devices? We don't really have any information about them yet. Now, because of prior knowledge, I already am familiar with the host names here. The other trick that we can play is, well, let's look at the DNS server. Earlier this week I showed you the DNS. Let's walk through that really quickly too. So we use PowerDNS for our authoritative DNS server. There is this PowerDNS admin web portal. It's not required. It's a separate piece of software that we run alongside it. But I'm lazy. I find it useful. Why not? And interesting. I don't see a camera that's specified as though it's running at the site that we have here. Because this camera is a picture of Midtown, that means that it's running at our SCO site. I don't see a camera running at SCO when I look for CAM entries. What about SCO? Stream? That's probably not it. So it seems like we're actually missing a DNS entry. Well, that's fine. We can do our little bit of reconnaissance again. Why not? So let's do a little bit of nmap action. Let's just run through the whole subnet. And we know there's 13 devices identified. So I'm imagining that we're going to find 14 or maybe even more devices that are responding to ping, and then have specific ports open. So while that's running, because that's going to take a second, what we could do is go ahead and look through some of these other devices, because we did see cam.hill. And when I looked here, we see this device. Oh, that's fun. I am not familiar with that error. Okay, makes it really obvious right in the title here, cam1.hill. So if I remember right, this device, once again, it is running RTSP. So let's do a quick nmap just to confirm. Oh. Now, making some assumptions here. Ideally, I would just be signing into the administrative portal for Blue Iris, but I'm going to be honest. I don't remember the admin credentials for it. That's something that Sam manages, so I'll leave that to him. Now, here's something interesting. It's using RTMP on port 1935. So that means for our configuration of monitoring cam1.hill, we care about checking for a TCP connect successfully occurring on port 1935. Let's manually build that URL just to make sure it works. Probe success 1. Awesome. So now we have the second URL that we're going to monitor. All this stuff I'm doing here in the GitHub comments, this is just for my own notes. It's not because it's required or expected, to be honest. Let's jump back to this port scan that we did. I think we found a number of devices that don't have reverse DNS entries. We've got something that only has port 80 open. That's interesting. That's a UPS, okay. Something with 222. On HamWAN, we've actually rewritten port 222 to be where we SSH, just to avoid port scanners, because it's such a nuisance. So, very interesting. I don't see any devices here. We see 16, 9 hosts are up. None of these are running RTMP or some related media protocol. So maybe my memory is not serving me well here. Very well could have it be where we have another subnet on the network there or something of that sort. So let's go look at the configuration of one of those routers. As a reminder, you can sign into the router, but more interestingly, we run a routine audit of all of the routers and their configurations, and we push them up to GitHub in this configuration repo called router OS config audit. Consider this like snapshots of the router states. So let's go and look for the router configuration at SCO. If there's another subnet here, I would expect to see on the OSPF network a second entry, but I don't see that. So that means the device is somewhere, but I'm not able to find it. We're going to have to return to that one. Now, I think this is going to come in handy for the last couple of cameras, because if you look at Blue Iris, there are a couple other cameras which, once again, I just happen to know that this camera and this camera both exist at our new site that's live in Olive Branch. We call that site CRW because it's the Craft Road Water Tower. And so I want to look for configuration of these CRW devices. Something I happen to know, just once again, it's kind of institutional knowledge, is that we have multiple networks on this specific site. Now, I didn't see it on that device, but perhaps we will see it on this device. Okay, here we go. We have one interface, switch bridge, which has IP addresses actually on two networks. 129.148, or which 144, and 129.122. So let's go and look once again. I always find that DNS ends up being helpful for us. So let's go and look at, oh, this is DNS. Well, I say it's always helpful. It's not helpful tonight. Can I ping the device? Let's do a network map of this subnet. Let's see what devices are live. I expect that there are going to be 3. There's going to be a router, there's going to be a webcam, and then another webcam. So one device is going to have port 222. There we go. And then the other devices are going to have all these other ports. Now what we care about is our TSP once again. We want to see that the device is streaming video and that's responding to that. So what this means is that this address and the other address are what we ultimately care about. So let's try that. Did I type that wrong? Oh yeah. So once again, let's try that first one. Let's try that success. Great. Awesome. What about this other device? Probe success 1. That's also up. Fantastic. So those are 2 webcams that we know are based out of Craft Road Water Tower because they're routed on a subnet on this specific device. Now, once again, there's this weird institutional knowledge I had there about the deployment pattern at Craft Road. That really just takes being familiar with how things were deployed. I could show you a camera picture. I could show you some plans that we drafted about 1.5 years ago, but I don't really have that in good documentation space right now. I think the more important issue is if you saw reverse DNS for this IP address is wrong. So I'm going to go ahead and at least here in the moment fix the DNS entries for these. So let's actually delete this DNS entry. Let's make sure that there isn't a DNS entry for this other guy. Nothing there. Let's also make sure that the routers, or really the default gateway, doesn't have anything. It doesn't. Okay, cool. So what is the router device? We know it's the thing that's responding on 222. Its IP is .129.145, and we know that this came off of r2.crw. So what are we going to name this? Well, we'll just name it r2.crw again. We've got 2 entries for that now, but they're both bridged on the same interface. You saw that before, where 117 and 145 are both there on the same interface. So I don't feel too dirty about doing that. But let's go ahead and add an entry. I'm just going to call this cam1. I don't know that's what the host name for the device originally was, but today it's our first camera there. And then I'm going to add a cam2. And so then I'm going to apply the changes. It's going to take a second here. Oh, that's not going to work. Yeah, I'm not remembering how to dig for a reverse DNS lookup. If you remember how to do that, one up me, add it in the comment or add it in the chat. But we'll move on for now. So we made things better. We documented what we were missing along the way, and then now we can get back on task. So if we look at the Jira issue, the GitHub issue, we now have 4 monitor URLs that we know are much, much closer to what actually represents the 4 camera feeds here. If we monitor those 4 things in Prometheus, then we're going to know with almost certainty that it's working here in the dashboard. So those are some good monitors. What about this 5th one, the thing at SCO? Let's dig around on the devices at SCO just to see if we can discern anything from those. So what do we have? We have router 1. Okay, so it's going to be a router at the base of the tower. We have Wi-Fi. That's going to be a point, like a Wi-Fi hotspot inside. We have sectors. And then we have a point-to-point link going to the bonner. So if there's going to be a spot that has another subnet for a webcam that we can't see, it's going to be router1.sco. But I don't think that's actually what's going on, because if I look at IP address, we've only got one IP address entry. So there's not another subnet that this is actually routing. What I think might be happening actually is I think there could be a filter. I think there could be a firewall filter at some place. So let's look for that. So in router OS, what we're looking for is, why won't it let me search for that? It's full text. That's very strange. In router OS, what we're looking for is an instance of firewall filter. The specific name or command space that exists in is IP firewall filter. I think that we're going to find that there's an IP firewall filter configured somewhere that's preventing us from getting to that device. I just don't know where that is. And so I don't know that I'm going to make significant progress there tonight. That's something I'm going to have to dig in more to. So I'm going to leave that for later. Now let's talk about how do we configure Prometheus to actually scrape these darn things. We know what URLs we want Prometheus to go to pull the stats, and then once those things are pulled, we know that we can configure some sort of alerting off of it. So I mentioned that we're going to be working on our configuration for Prometheus at the end of the day, because that's where we tell it what stats to pull. So let's go ahead and make a branch here. So we're adding a feature, monitor IP cams. So we've started our own branch, and when we jump around here, we're going to find that there's a role that we were looking at earlier, or sorry, what do they call it? I forget what it's called in Fleet. Anyway, a folder named Prometheus, and in there fleet.yaml. This has our Prometheus configuration. We want to tell Prometheus to start scraping for network cameras. And we know the closest thing to the format that we want was the instance of that TCP connect that we saw for All-Star. So let's use that as the prior art that we borrow. We want to look for the All-Star job where we're using the TCP Connect module. So we are just going to copy and paste this job for now. And let's name it something descriptive and relevant for, what is Prometheus scraping? What is the thing that it's doing? Well, it's keeping track of the IP cameras. The metric path is /probe. That's still correct. If you look at all these URLs, they have /probe, /probe, /probe. You don't have to worry about changing that. Targets. Well, before that was All-Star and it had this port. Now we have all these new values. So let's go ahead and start making use of them. So the first host is this. But something looks different here. We've got allstar.lab, a port. Here we've got %3a. What's %3a? Well, %3a, with a quick Google search, you'll find it is the URL encoded value of a colon. So all that is it's somewhere colon got turned into %3a. Now the reason it does that, the reason Prometheus does that is to make sure that the URL is well formed and that various hosts besides Blackbox exporter will be able to make sense of it. let's not worry too much about that. I just happen to know, once again, from prior experience, that we want the actual colon here. The fact that it turns it into a URL escaped value is not so significant. So we have cam1.hill. This is interesting. It's on a non-standard port, or at least not standard to me. I don't know. 1935. And then we have this IP, which I'm hopeful, now that we've added DNS, we can just actually update to have a pretty name. This one was 148. Now let's see. Did our DNS entries go? What did we call that? It was cam1.crw.memhamwan.net. And that worked. So we can go ahead and replace these. Now I'm just going to go ahead and add it to do. And you know what? Let's make an assumption. I wonder... Oh, we don't know the IP. I can't just try to brute force it because we don't know the darn IP. Okay. Well, we'll leave that for another day. We'll have our to-do there. Relabel configs. What does this do? Well, it says for the source label of address, replace it with the parameter target. For the source label of parameter target, replace it with the target label of instance. What does this mean? Well, this honestly, it's all copy pasta. This is stuff that came from the blackbox exporter GitHub configuration. Ultimately, the whole purpose of that is to make sure that when you look at the labels on here, the labels and the targets and the modules are actually in sync, because we're doing something a little bit weird here. Normally, targets are the things that we scrape. But in this case, actually, what we're scraping technically is this in-between, this proxy of the blackbox exporter. And then it, in turn, is targeting these other hosts. So this whole relabel configs, the whole reason that's there is to handle that weird usage of blackbox exporter and make it in a meaningful way where it shows up here as though we are directly interacting with these various instances, even though we're not, even though we're actually calling the black box. So I think that this looks pretty good. We've got our 4 cameras. We've based the targets off of the ports that we know that work. The module's the thing that we want. We've given it a descriptive job name. Let's go ahead and make a commit. So, unfortunately in this space, we actually don't have automation to verify this change. There's no good way to test this today unless you were to run Prometheus locally. I'm going to opt to do something a little bit dirty and fast and quick, and I'm just going to land the change. This runs some risk. Things might break, but hey, I've got 5 minutes until I need to be offline, so okay. Worst case scenario, I roll it back if things don't work, and we'll just call it a day. So I'm going to tag or label my issue as Fleet since we're using Fleet. And the label is Prometheus since we're changing Prometheus. There's no concerns here. Squash and merge. So once again, if things blow up, things go badly, we'll just revert it. That's not such a big deal. So what happens now? Well, we have continuous delivery set up using a platform called Fleet that watches for this repository's master branch and then automatically deploys the changes that we've committed into our production Kubernetes cluster. So let's go look at that. If you go back to our dash here, our big dashboard of stuff, our Kubernetes management portal that we're using is Rancher. I'm going to sign in to Rancher. And then from here, I'm going to jump into the Cluster Explorer. We only have one Rancher Kubernetes cluster today, so it's pretty obvious where we're going. And then here at the top right, or top left, I'm going to jump from Cluster Explorer to the Continuous Delivery feature. This is Fleet. This is a management portal for Fleet. And if you look, right now it has a configuration for a Git repo that's infrastructure configuration. It's watching this repository. And if we go look, we can see a number of resources. That's the word I was looking for before. That are configured based off of the repository. And you can see where 38 seconds ago, it accepted changes from the repository. Now there's a failure here related to a different bundle of different resources. That's okay. We'll ignore that for now. Everything will still work just okay, even though that error is there. But what this tells me is Fleet has identified that the Git repository has changed. And you can see that it's monitoring master and it's looking at the commit with hash 8443D, which we do a git show. It's not the same thing. However, why is it not the same thing? That's because we're taking a rebase strategy. If we pull down latest master, we're going to see here in a moment 8443D. So that means that our continuous delivery system has already identified the new merge request, got landed, master got updated, and that it needs to do something. So it accepted the changes. If we go and actually look at the cluster exporter, we'll be able to see the state of the various pods. So some of these things aren't in a great state. They're half-finished projects, but some of these things are in a very good state. Like in our case, we're looking for Prometheus. Oh. Oops. So you can see there are multiple instances of things named Prometheus. What we care for is Prometheus server. And if you look, it's been running for 27 days. So it didn't restart. What's interesting is you can see it's got something called config map reload. That is one of the images that Prometheus server is running. So what that means is that the Helm chart that we use for Prometheus is using a tool called config map reload. It's looking for when configuration maps change, and it's reloading the application in the container as it runs, as opposed to tearing down the pod and standing it up new. So if we go, let's look at the config map. I'm going to expect that we have a config map that is containing that Prometheus.yaml that we were looking at before. Just take a look. Here's Prometheus.yaml. And here are the static configurations, the targets that we've specified. So that means that our change made it into the Kubernetes cluster. It has the config map for the configuration file live in there. And then based off what we just saw, it's safe to assume that Prometheus server has restarted now, given the new configuration map, which in the Prometheus world gets mounted as a volume, going down to the actual Docker container, and that's just a file in there for it to pick up. So let's jump over to Prometheus, and if I refresh this page, fingers crossed, we should see IP cams. IP cameras, 4 up. There we go. So what have we done? We've made it where now Prometheus is scraping configuration from blackbox. It's saying, hey, tell me if TCP port 554, or in this case 1935, are running on these IP cameras. So now Prometheus is going to keep track of whether these devices are accessible, whether they respond to TCP, which is as close as we can get to knowing whether Blue Iris is actually able to get a camera feed off of it. It doesn't monitor Blue Iris, but it monitors the fact that Blue Iris could TCP connect to the cameras. If one of these fails, we have existing alert manager configurations that will make it where we get paged. If we find that there are instances of a device not being accessible, this is a part of a Prometheus rule. If an instance is down, then what's going to happen it's going to make a severity page after it's been down for 5 minutes. So the fact that we see these target entries saying there's 4 devices, the fact that we have 4 targets that maintain the state of up or down, plus the fact that we have a rule saying send a page rule, a page instance, if an instance is down. That means that if one of the IP cameras goes down, maybe it still responds to ping, maybe the admin interface works, but if the video feed stops working, we're going to get an alert, which based off of our alert manager configuration is going to send a chat to the NetOps channel. So let's go ahead and call it a night there. What have we successfully done tonight? Well, we can go ahead and jump over to our configuration repository, and we can say that adding cameras to monitoring, this is done. And we will close this issue. So thanks everybody for joining me tonight. I know this was a bit different pace compared to the previous live cast. Today's topics included technologies like Git, technologies like using YAML configuration files, weird nested use cases where YAML sub-objects represent things that ultimately become files that also use YAML. So it's a little bit of a funny use case. Kind of nested in there, and I didn't really talk about it, was something called Helm, which helps manage deployments and other configurations of Kubernetes objects and resources, and templatizing those. Then we talked about, of course, Kubernetes. In Kubernetes, it's managed using something called Rancher Helm, which introduces continuous delivery to that system. I introduced you to the Rancher web interface and the node manager part of that, and the continuous delivery portion of that. And then, of course, I also walked you through, once again, just a little bit of network snooping using nmap to kind of jump around different subnets and get a sense of what devices are listening